first lesson of our next unit titled Ratios and Proportions. And this should feel a little bit like a review. You probably covered this to some extent in algebra and pre-algebra. So hopefully this will feel like a nice review of what you've covered in the past. So first thing, let's define a ratio. So a ratio is a comparison of two quantities by division. And you can see ratios written in different ways, either as a fraction, or you could have A and then colon B, or A to B, you could express it. You usually express A and B in the same unit, and you usually write the ratio in simplest form. So to start off, let's actually just practice writing ratios. So here we're given some information about two different types of trees. We have a bonsai bald cypress tree is a small version of a full-size tree. A Florida bald cypress tree called the Senator stands 118 feet tall. What is the ratio of the height of the bonsai to the height of the Senator? So we have the bonsai right here, and we want to write a ratio of the height of the bonsai to the height of the Senator. And do keep in mind whatever is stated first, you want to have that on top or written first. So the height of the bonsai, we can see here, is 15 inches. And then the height of the Senator is 118 feet tall. So based on what we did before, I mean, that's not wrong. I could say the ratio is 15 inches to 118 feet, but it's typical to see the ratio in the same unit, and to write it in the simplest form. So let's go ahead and practice that. So a few different ways I could change this ratio. So I could divide 15 by 12 to get the amount of feet it is. But notice that's going to give us a number less than 1. And let's try to keep our numbers as whole numbers in our ratio. So instead, let's convert this 118 feet to inches. Since they're 12 inches in a foot, I'll multiply by 12. 118 times 12 is 1,416 inches. My top quantity is still in inches. So this is good. I now have both of them in the same unit, but let's check and see if we can simplify this ratio, which I actually can. So both of these numbers are divisible by 3. So 15 divided by 3 is 5, and then 1,416 divided by 3 is 472. All right, so that's my ratio. And notice in this, because they're in the same units now, I don't even actually need units here. I can just say my ratio is 5 to 472, whether that was inches, feet, centimeters. We now have that comparison we can make. All right, you guys pause the video, and I want you to do our practice number 1. So a bonsai tree is 18 inches wide and stands 2 feet tall. You want to find the ratio of the width of the bonsai to its height. So instead of comparing two different trees now, you guys are going to compare width to height. Pause the video, try it, and then check your work. All right, so just be careful in converting your units, guys. So you're looking for your ratio of the width to the height. The width is in terms of inches, the height is in terms of feet. So you just want to convert one to the other. The easiest way is to convert your feet to inches. So multiply by 12, which gives you 24 inches. And then just simplify your ratio. You can divide both the top and bottom by 6. So your simplified version of your ratio in the same units is 3 to 4. All right, moving on to this problem here, a little bit different, this type. So members of a school band are buying pots of tulips and pots of daffodils to sell at their fundraiser. They plan to buy 120 pots of flowers. And I'm just gonna kind of make note of that. So that's for the total combined. The ratio of the number of tulip pots to the number of daffodil pots is 2 to 3. How many pots of each type of flower should they buy? So just really be careful with a problem like this, guys, and making sure you're understanding what each number represents. So I already labeled, we know that's the total, and I'll just kind of make note that includes the tulips plus the daffodils. And then this ratio isn't part to whole. The 2 to 3 here, you guys see 2 represents the tulips and 3 is for the daffodils. So it's not like 2 tulips to all of them. So just be careful if you're rushing through this, you might be solving this incorrectly. So I'll show you guys the way to approach this. You could use a proportion, but for this one, I'm going to show you guys, I think, an easy way to approach. So you know that 2 is for the tulips. So I'm just going to say, okay, 2 times some number will give us the number of tulips we're going to get. 3 times some number will be the number of daffodils. And then I know the 120 is the total. All right. So I can figure out what that number is going to be by combining like terms and then solving for my variable. So I'll combine, I get 5x. 120 divided by 5 is 24. All right, and that tells me what I need to multiply to keep that consistent ratio. So to find the tulips, I now need to do 2 times 24, which is 48. And you could subtract that from 120, but I'll just stick with working with this ratio. So for the daffodils, I'm going to do 3 times 24, which is 72. All right. And that makes sense, right? When I add up 72 plus 48, that does give me 120. All right. So you guys pause and try number 2. A little bit of a different question, but similar idea. We have a ratio of the 2 angles. These are the individual angles, and we know they add up to 180 because they're supplementary angles. All right, pause the video, give it your best attempt, and then check your work. All right, so here are your answers. Kids solve this by setting up this equation. We know the ratio is 1 to 4 for the angles we're given. We know the total is 180. So combine those, you get 5x. Solve for x, you get 36. And that gives you one of your angles, right? Because it's just 1 times 36. And then to find your other angle, 4 times 36. And you can always check your work. 36 plus 144 does give you 180 degrees. All right, this one here. Similar, so using an extended ratio, the lengths of the sides of a triangle are 3 to 5 to 6. So here, I mean, instead of comparing 2 quantities, we're comparing 3. That's the only difference, guys. So this is our extended ratio of our 3 different sides. And we know the perimeter is 98. So we're still approaching it the same idea, only we have 3 quantities that add to some total. So what is the length of the longest side? I kind of like this diagram they already have for you. They're showing you how you could express those sides. We don't know exactly what they are yet, but we know their ratios. So I'll set up my equation. 3x plus 5x plus 6x is 98. Add up 3 plus 5 plus 6. We get 14x equals 98. 98 divided by 14 is 7. Okay. And then what is the length of the longest side? You can find all of them, but let's just find the longest side. That's going to be this side here, which we multiply by 6. 6 times 7 is 42 degrees. Oh, wait, sorry, not degrees. Inches. All right, number 3, you guys pause the video. Try it, same idea, only working with 3 quantities instead of 2. Here's the setup of your equation. Solve for x, and then don't forget to plug in to solve for each side now. So 4 times 3, 7 times 3, 9 times 3, you get 12, 21, and 27. You can always add those up to check your work, and they do add to 60 centimeters. All right, now cross products property, you guys might think of this as cross multiplication. So they're just reiterating here, in a proportion, the product of the extremes equals the product of the means. Right, we often will see these circled. You can multiply A times D and B times C. You can set them equal to each other. All right, and they show you an example here. All right. So I also included this. I think this is nice to show you guys why it works. So yeah, we can go through the motions of it, but it's showing you algebraically, it's not like you're breaking any rules here. So say if I were to try to prove that multiplying the cross products is okay, you could prove that by multiplying by BD on both sides, as you guys can see here. And then when you do that, the B's cancel on the left side, the D's cancel on the right side, and then you're left with A times D equals B times C, right? And remember, the reason why you can do that, right? B times D, when you're multiplying by the same thing on both sides, you're not breaking any rules, right? You're balancing your equation. All right, so let's solve these proportions. And notice for part A, guys, it's not like I could easily, like, say if this was a 3 instead of a 5, I could just divide 6 by 2 to get to 3. So then I could say, oh, x would be 8. So using the cross products properties isn't something you need to use every time, but you'll see a lot of problems in which it is going to be helpful. So I'm just going to circle these so it is clear how you're setting this up. I'm going to multiply 6 times 4 and set that equal to x times 5, or I'll just say 5x. 6 times 4 is 24. Divide by 5 on both sides. We get x equals 4.8. This one, where we have y showing up in 2 places, that's okay. We'll still apply the cross products property. So I'm going to set those equal. So y plus 4, the entire quantity times 3. So just make sure you're multiplying y and 4 times 3 equals 9 times y. Distribute the 3, you get 3y plus 12 equals 9y. Subtract 3y on both sides. Oh wait, sorry. That looks like an x. 9y, there we go. Subtract 3y. Get 12 equals 6y, and then divide by 6. Y equals 2. All right, you guys pause the video. Try number 4, A and B. Okay, here are your answers for these. So A equals 63, equals 1/4. So if you got 3/12, just remember that you want to simplify your fractions to get into good habits with that. Divide by 3. Divide by 3, you get 1/4. All right, last concept, guys. So writing equivalent proportions in the diagram, you could write the proportion of x over 6 equals y to 7. What ratio completes the equivalent proportion? So just look at their positioning here, right? So if you have x, let's see, x to 6 equals y to 7, you can rearrange those. So if we have x to y, we would then say that that equals 6 to 7, just kind of using your common sense and looking at the placement of those. But I want to show you guys too, algebraically, why that makes sense, why you can do that. So x to 6 equals y to 7. I could justify by answer and showing that x over y equals 6 over 7 if I wanted to, let's first get, because we want to try to get y here instead of this 6. So I'm going to try to get 6 on the other side. I'll do that by multiplying by 6 on both sides. I'm then left with x equals 6 times y over 7. And then to get y in my denominator on the left side, I can just divide by y, right? Which is like, you could think of that as multiplying by 1 over y. Divide by y, cancels on the right side, and then I'm left with x over y equals 6 over 7, which I got before. Right? I'm not really going to ask you guys too often to try to rearrange it, but I just want you guys to see it's not like it's not like it's just coming out of nowhere.